Hello and welcome to Contemporary Math lesson for 3A. The uses and abuses of percentages. So very quickly here, I just, again, like to go over what words mean so that we can understand what they are, and we'll go over how to work with these in a minute. So right off the bat, we have this word percentages or percentage, and really, literally, it means per 100. And as you can remember, per means divide, and 100, at least over in the metric system, usually ends up using the prefix cent, like centimeters or centiliters. So per 100 makes a whole lot of sense here. No pun intended. So as you can see in the next line, it says divide by 100, per 100, right? And we can also refer to percentages as rates. What makes rates different, we'll talk about in a second here. So percentages can be represented three ways. One, as a fraction of a number over 100, and yes, you may have to simplify. But we can do that. We have the ability to simplify fractions. Percentage could be represented as a decimal, which when you actually make the division by 100, you'll get a decimal form of a percent. And that is what is known as the rate. Or the fraction could also be known as the rate. So we have these two ideas. And then lastly, the percentage uses the percent symbol. And that's how really you can tell the difference between them. So let's take a look at converting between percents and decimals and fractions. So very quickly, before I get too far into these examples, I want to make sure you all see this. In this first column, we will have fractions. In the second column, we will have decimals. And in the last column, we will have percentages. So converting between these three forms here, we will have to keep straight some steps just to make sure we understand what's going on and how to convert them. So if you're trying to convert a percentage to a common fraction, the percentage should be put in the numerator, 100 should be put in the denominator, and then we would simplify. And so what this means, I'll go through and do an example of all of these so you can see what's going on, is I'm just going to look at 50% here, and I'm going to do some work over here on the left side. So if you want to change 50% into a fraction, you want to take the actual number of the percent, in this case 50, divide by 100, and simplify that down, which in this case would be 1/2. So there we go. Now, changing a percent to a decimal is very, 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 very similar. So this would be the fraction. If you want to change the percent to a decimal, you would actually just type this into any old calculator, 50 divided by 100, and it would give you something back like this, 0.5 or maybe just 0.5. But that's it. So we know that percent, we know the decimal would be 0.5, and that's it. Percentages into any other thing are usually pretty easy. All right, if you want to change a decimal into a percent, you have to multiply the decimal by 100 and then attach the percent symbol. So let's find a decimal here. Let's do this one here. 0.43. So if you want to change a decimal to a percent, all right, decimal to a percent, 0.43. Multiply that by 100. And again, if you're not very good with the multiplying things or moving decimal points, go ahead and use a calculator. But when you multiply these two numbers together, you get 43, and you'll put the percentage symbol next to it, and that's it. Like, that is the percent. That's exactly how you do it. So what do we get? 43%. And now if we wanted to finish out this row for number 5, all we have to do is change the percent to a fraction, which we've already talked about. We divide just this number 43 by 100, see if it simplifies. It does not in this case, so it would just be 43 over 100. The very last thing we want to do is say a fraction to a percentage, and I'll do that with green here. So I'll pick, let's do this fraction, 2/3. So we will actually just divide so 2 divided by 3 on a calculator would be 0.666666667, because the calculator will correctly round. But then, once we have that, we will multiply by 100, right? If you have a decimal, when you divide, you'll get a decimal. Decimal to a percent, you just multiply by 100. And for the purposes of this video, we will go out 2 decimal places and round. So 66.67%. And we found the decimal along the way, and we will just go out 2 decimal places, because when you make that division, going from a fraction to a decimal is as easy as just plinking it in a calculator. So take a few seconds, fill in the rest of these rows. I will come back in about 10 seconds with all the answers. So all of the purple numbers here represent the answers that were not here before. I think the only one that might give any of you some issue is this last one. If you go from a decimal to a percent, you multiply this by 100. And when you multiply 3.5 times 100 in any calculator, you'll get 350. That is not a typo. There are many applications, the most easy being like the stock market. The growth of a stock can easily get higher than double what it started. It can have a high growth. And then going into a fraction, you would divide 350, the percentage, you would divide it by 100, and that fraction would simplify down to 7/2. On this slide, we will go over a slightly different way to compare two numbers, that being a ratio. So a ratio is a comparison of two quantities. You can express a ratio in words, you say A to B. Using odds notation, we still say A to B, or as a fraction, which we'd still say A per B or A divided by B. Because the comparisons make sense only when comparing quantities with the same units, ratios always end up without units. Let's see how this works in the next example. So suppose the price of a BMW is $80,000 and the price of a Honda is $20,000. That doesn't sound too far off. So the question is, what is the ratio of the BMW to the Honda? So the ratio, let's see, we would need to come up here and look. The ratio of BMW to the Honda. So that looks a lot like this form. So I know the BMW will be A and the Honda will be B. So let's see. I think the easiest way to do this would be, if we're trying to actually find the ratio between these two, is just to use a fraction. So the A would go on the top and the B would go on the bottom because the A, and because the A is BMW, we will put 80,000 on the top, and we will put 20,000 on the bottom because the B is the Honda. So let's divide this out. We would get 4 over 1, which is 4. And let me back up here, dollars and dollars. So the units of dollars would cancel, leaving us with just a ratio of a whole number. So what does this number mean? We could interpret this as being the BMW is 4 times the Honda. Now over here for the second example, it's going to be something very, 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 very similar. But it's in the reverse order. So now the Honda is A and the BMW is B. So if we convert this one into a fraction, it would be $20,000 over $80,000. And if you simplify this fraction down, the units will again cancel, leaving you with 1 over 4. And what this means is, as I run out of space, the Honda is 1/4 the cost of the BMW. So the very last piece of this that we're going to look at here is part C. The BMW is what percentage of the Honda? So in order to understand what's going on here, whatever happens after the word of, so we'll say of the Honda, that amount will go into the denominator, and whatever other piece we're looking for will go into the numerator. So if we do this, $80,000 divided by $20,000, right? It's just slightly worded differently from part A. We already know that this should be 4, but we're trying to make this a percentage. So if we know our decimal, and yes, this is a decimal, and we're trying to make a percentage, all we have to do then is multiply this by 100 to get 400 and put a percent after. So the BMW is 400% the cost of a Honda. And I just want to point this out. Sometimes percentages can be used to say silly statements like this: always give 100%. In life, in your career, in school, give 100% unless you're donating blood. Hopefully you all can find the humor in that. Let's take a look at solving percent problems now. And I'm going to actually start out with these two formulas down here. They will help us out with these two examples. And more specifically, this first formula here will help us out with this example, and this next formula here will help out with this example. So for example 1, we'll get to this one after these two. You purchase a shirt with a labeled pre-tax price of $17. The local sales tax is 8.25%. That is true in the Houston area. It is that. What is your final cost including tax? So all we're going to do is we're going to set up our equation here. I'm just going to call it F for final cost. And I'll have 100 plus the P being the tax rate, or the other percent that is not or that is mentioned. So this will be tax, 8.25% times $17. Now, percents do not play well in equations. So if we add this together, we get 108.25% times 17. So we have to change this to a decimal, which means we just take this number and divide by 100 and get 1.0825. And when you deal with percents in equations, you always must change it over into a decimal. Then you can perform your operations and you'll get something like $18.40 for the final cost of the t-shirt or shirt. So again, you have to make sure you're working with decimal equivalences of the percentages in the equations. So let's take a look at this second example here. It says your receipt shows that you paid $19.26 for a Blu-ray disc, tax included. The local sales tax is 7%. What was the labeled, aka pre-tax price of the disc? So we would just use this formula down here. If we can set it up, I'm going to use L for labeled price equals the final cost, which was $19.26, all over 100 plus 7%. So I don't think the math here is too hard. 100 plus 7 is 107%, but we need to change it over to an actual decimal. So this percentage as a decimal becomes 1.07. And when you make that division, you'll find out that the sticker price or the pre-tax price or the labeled price was $18. Now lastly, this example up here, this one is a little odd. It says a newspaper reports that 44% of that many people surveyed said the president is doing a good job. How many people said the president is doing a good job? Anytime you are taking the percent of something, which is a little bit different from what we did above up here, we have to basically set up a fraction. So this would be, we don't know how many people. In fact, we'll call it the number of people that say Prez is doing a good job. We can set up a fraction since we don't know that. How many people out of 1,069 would be 44%? Well, we can multiply both sides by 1,069 to cancel this out, and I think we get to an equation that most people would understand as 44% of multiplied by, what is this? 1,069, which is about 470 people. And 470 people out of 1,069 people say the president is doing a good job. On this, the final slide for this video, we have abuses of percentages. Percentages can be so subtle, so people end up misusing them, sometimes inadvertently and sometimes deliberately. I think a little further down, there might be this example, like in a very real life example of the abuses of percentages, are that people think that if you go into a store with a 50% off coupon and a product was marked down 50%, then you get the item for free. Well, sure, because 50% marked down and the other 50% off with the coupon, it should be free. And that's not how it works, and I'll come back to this at the end after I do all these examples, or maybe you can figure it out along the way. So we have this first example here. Because of losses by your employer, you agree to accept a temporary 10% pay cut. Your employer promises to give you a 10% raise after 6 months. Will the pay raise restore your original salary? The short answer for this is no. So here's the math behind it to prove it. Let's say just for a month you make $10,000, and usually 10,000 is such a great number to pick for any of these scenarios. So if you lose 10% of your pay for that month, 10%. So what is 10,000 times 10%, aka 0.10? That'll give you $1,000 pay cut. So if we subtract the $1,000, right, the 10%, you'll end up making $9,000 for 6 of those months, right? Then you will get a 10% pay raise later on. But the pay raise is based on this number here. So when you get a 10% raise, you will get 10% of $9,000, which I will write as 0.10 as decimal, which is $900 raise. So if you add $900 here, you get $9,900 per month. And that is not the 10,000 you started with. So this you can see why the answer here is no. The second example here. A stockbroker offers the following defense to angry investors. I admit that the value of your investment fell 60% during my first year on the job. This year, however, the value has increased by 75%. So now you are 15% ahead. We're just going to ask, double check this stockbroker's numbers. Is the stockbroker correct? Well, again, if you start out with, 10,000, and you multiply by 60%, aka 0.60, you will get a $6,000 decrease in the value. So we will subtract $6,000, and then we will be left with, $4,000. But then later on, the value increased by 75%, but not of your original of the 4,000. It's very similar. Increase 75%. So over here off to the side, I'm going to do that. $4,000 times 0.75 is $3,000 increase. So we will add $3,000, and clearly you are not, you are not 15% ahead. So let's take a look at these last few examples down here. We often see numbers that represent large, more than percentages. For example, a price of $40 is 300% more than a price of $10. However, in most cases, it is not possible to have less than percentage that is greater than 100%. Again, this is super common over in the finance world, the investing side of life with stocks and bonds and all that. A stock can grow in value 200%, which means, as weird as this is gonna sound, which means it was 3 times the original value. But it doesn't matter how much the stock is, you cannot lose more than 100% of the value. If a stock is worth $100 and it goes down to 0, it lost 100% of the value. If a stock is worth thousands of dollars, like Amazon, and it goes down to 0, well, it lost 100% of the value. You cannot lose more than 100%. So a very quick example of like an abuse of this would be an advertisement claims that by replacing standard light bulbs with energy efficient ones would use 200% less energy. And that is impossible. You can't use less than 100%. So this one is, this is just a big fat no. 100% would be no energy. You can't use less than 100%. All right, the second example here, we have sale. 150% off all merchandise. One word. Free. That would be free. Like 100% off would be free. 150% off means they would pay you to take it. And that's a pretty sweet deal for any consumer out there. So if you ever see this sign, take advantage. And then, of course, this last warning down here, don't average percentages. Suppose you got 70% of the questions correct on a midterm and 90% of the questions correct on the final. Can you conclude that you answered 80% of the questions correctly? And again, right now, a very quick and fast no. You cannot conclude that. So an example would be if there were 10 questions on the midterm, 10Q on midterm, then you would have gotten 7 questions right to get a 70%. If there were 100 questions on the final, you would have gotten 90. You would have had to gotten 90 correct in order to get a 90%. So out of a total of 110 questions, you would have gotten 97 correct, which is way bigger than 80% of the questions correct. So do not average percentages. It will very rarely work.